China has achieved the impossible on the moon's far side, a region no one has ever fully explored. Chang'e 6 returned with discoveries that have left scientists around the world shocked. The samples hide secrets billions of years old, capable of changing what we thought we knew about the moon and the solar system. NASA and SpaceX did not expect this, and the story is just beginning to unfold. The hidden hemisphere. The moon has always watched us from above, but it has never shown us its whole face. For all of human history, one half of the moon remained hidden, turned away from Earth like a silent guardian keeping its own secrets. This is because the moon is tidally locked to our planet. It spins at the same rate that it orbits Earth, so we only ever see one side. The same craters, the same bright streaks, the same familiar pattern. The far side stayed unseen and untouched, not because it was in permanent darkness, but because its day and night cycle lasts almost 29 Earth days. It received sunlight, but no human eye or machine ever stood on its soil long enough to study it closely. Because of this strange locked dance, every lunar sample ever brought back by the Apollo missions from the United States, the Soviet lunar missions, and even the recent Chinese Chang'e 5 mission came only from the near side. Scientists had moon rocks, dust, and core samples, but all of them told the story of only one hemisphere. The other side, the far side, remained a blank chapter in the moon's history. No one knew what it was made of or how it evolved. Researchers suspected that there must be major differences, but without physical samples, all ideas were guesses. Over time, new data from lunar orbiters confirmed that the far side was not just unfamiliar. It was fundamentally different. The crust there is thicker. The surface is covered with many more impact craters. And the dark volcanic plains known as Maria are extremely rare. On the near side, these plains form the shapes that look like eyes and a mouth when we see the full moon. On the far side, almost none exist. This suggested that billions of years ago, the moon's two sides lived very different geological lives. One cooled faster. One held heat longer. One was shaped by intense volcanic activity, while the other remained stiff and quiet. But without samples, scientists could not test their theories. Landing on the far side brought its own challenges. Because it never faces Earth, no signal could reach it directly. Engineers needed a relay satellite resting far the moon so it could bounce communications back to Earth. Designing such a mission required precision, advanced technology, and a willingness to risk everything. No nation had ever attempted, let alone completed, a sample return from the far side. Let's tell you complete details of a mission that dared to face the silence, break through the darkness, and challenge the unknown. A mission that prepared to bring back secrets hidden for billions of years. China's game-changing mission. The journey of China's Chang'e 6 began on the 3rd of May, 2024, when the spacecraft lifted off from Wenchang on Hainan Island. The launch was smooth, confident, and carefully planned. But everyone watching knew the real challenge lay ahead. The destination was the far side of the moon, a place that had remained untouched and unexplored since the dawn of space travel. On the 1st of June, 2024, Chang'e 6 achieved what many once thought impossible. It touched down inside a chosen landing zone deep within the South Pole Aitken Basin. This basin is not just another crater. It is one of the largest and oldest impact sites in the entire solar system. Stretching about 2,500 kilometers across, it was carved out more than 4 billion years ago by a massive collision. Inside this ancient scar lies the smaller Apollo crater, the exact region where Chang'e 6 settled. It was a place shaped by cosmic violence and frozen in time. Once the lander stabilized, the mission began its delicate work. Chang'e 6 carried both a robotic arm and a drill. These tools reached out and dug into a world that had never been touched by humans or machines before. The arm swept up lunar soil from the surface, while the drill reached deeper, pulling up hidden layers that held secrets from the moon's earliest days. By the end of the operation, the spacecraft had collected 1,935.3 grams of material. It was a historic moment. For the first time in history, samples from the far side of the moon were safely stored on board a spacecraft. But collecting the samples was only half the challenge. The real test was getting them home. On the 6th of June, 2024, the Ascender module lifted off from the far side, carrying the tiny container filled with priceless lunar material. It rose into orbit and docked with the waiting orbiter. There, the container was transferred into the return module, a process that demanded perfect precision in the emptiness of space. After the handover, the return capsule began its long journey back to Earth. It marked the end of a mission and the beginning of a new era in lunar science. The world waited as the capsule was opened. Scientists expected valuable data, but what they found inside reached far anything they had imagined. But that historic sample return was only the prelude, because once scientists opened that capsule, what they found went far: moon dust and rock. The unexpected revelation. When scientists first opened the Chang'e 6 sample container, they expected new insights but nothing earth-shaking. Instead, they found something that stopped them in their tracks. Mixed within the grey lunar soil were tiny fragments that did not belong to the moon at all. These pieces came from a rare kind of meteorite known as Ci carbonaceous chondrites. Their presence was extraordinary. Until this moment, no one had ever found such meteorites on the moon. On Earth, Ci chondrites are almost mythical in their rarity. They make up less than 1% of all meteorites ever collected. They are fragile, porous, and rich in volatile elements that usually disappear under intense heat. These meteorites carry water-bearing compounds, organic molecules, and even ancient pre-solar grains. Each grain is older than the Sun itself. They are like time capsules that carry clues about how the solar system formed. Finding Ci material on the moon shocked researchers because the lunar environment is not gentle. The moon has no atmosphere to slow incoming rocks. Every meteorite slams into the surface at full cosmic speed. Impacts on the moon do not simply crack a meteorite. They vaporize it in an instant. Fragile carbon-rich meteorites should not survive such violence. They should never remain intact long enough to be buried, preserved, and later scooped up by a robotic arm. Yet the Chang'e 6 samples proved that at least some of these delicate visitors did survive. The discovery forced scientists to rethink long-held beliefs about the history of the inner solar system. If Ci chondrites reached the far side of the moon and remained preserved, then Earth may have received far more water-rich and organic-rich material than once believed. This supports the idea that the early solar system was filled with countless ancient, carbon-laden objects that delivered the raw ingredients for oceans and possibly even the first sparks of life. The implications are stunning. The far side of the moon, silent and untouched for billions of years, turned out to be a vault storing evidence of a cosmic era older than Earth itself. These fragments are now guiding new studies on how water and carbon spread through the solar system. They also raise a deeper question that scientists are still trying to answer. But how did these delicate, water-rich meteorites survive the brutal nature of lunar impacts and remain intact long enough to be discovered? The forensic science that redrew lunar history. When researchers from the Guangzhou Institute of Geochemistry under the Chinese Academy of Sciences began their analysis, they expected unusual chemistry from the far side. Instead, they found 7 microscopic fragments that changed everything. Each fragment was smaller than a grain of sand, yet packed with clues older than the moon itself. These tiny pieces were olivine-bearing clasts with a porphyritic texture, all under 100 micrometers. Their chemical fingerprint matched something extremely uncommon. They were identical to Ci carbonaceous chondrites. To confirm this discovery, scientists used advanced mineralogical tools and precise oxygen isotope measurements. Meteorites from different parts of the solar system carry their own unique isotope signatures. When the team examined the ratios of oxygen isotopes, known as delta 17O and delta 18O, the results were unmistakable. These microscopic grains were not lunar. They were the same as known Ci meteorites. That meant they had drifted through space for billions of years before striking the moon and somehow surviving long enough to be buried and collected. The soil around these fragments also told an unexpected story. The far-side regolith brought back by Chang'e 6 had properties unlike anything collected from the near side. Its bulk density was lower at about 0.983 grams per cubic centimeter, and its true density was about 3.035 grams per cubic centimeter. Its mineral makeup was different as well. It held around 32.6% plagioclase, nearly 20% augite, 10% pigeonite, and only about 0.5% olivine. Most striking of all was its high content of amorphous glass, almost 30%. This mixture suggested a regolith shaped by intense bombardments, constant mixing, and layers of ancient ejecta thrown in from distant impacts. These findings support a much broader idea about the ancient history of the inner solar system. During a violent era known as the Late Heavy Bombardment, which occurred roughly 4.1 to 3.8 billion years ago, Earth and the Moon were showered with countless objects. Many of those objects carried water-rich and organic-rich material like Ci chondrites. The presence of these fragments on the Moon proves that such deliveries were not rare events. They were common and possibly essential to shaping both worlds. But the story did not end with those 7 fragile grains. Hidden deeper within the Chang'e 6 moondust, scientists found yet another surprise waiting to be revealed. The Moon's hidden fireworks. For decades, the far side was seen as a quiet place with little volcanic activity. Its crust is thicker than the near side, and this extra thickness was thought to prevent magma from rising. But once researchers began examining the basalt fragments brought back by Chang'e 6, they discovered a story filled with heat, pressure, and unexpected eruptions. Scientists identified 108 basalt fragments in the sample collection. When they studied these rocks, most pointed to a period of volcanic activity around 2.8 billion years ago. This was astonishing. It meant that the far side was not the frozen, inactive landscape many believed it to be. Instead, it had once pulsed with molten activity, shaping its surface with lava flows that hardened into rock. These findings filled a major gap in our understanding because most previous knowledge about lunar volcanism came from near-side mare basalts. The far side had remained a mystery, known only through remote sensing and distant observations. Then came an even bigger revelation. Among the many basalt pieces, scientists found one fragment that stood out from all the rest. Its age was dated to around 4.2 billion years. This made it the oldest precisely dated lunar rock ever returned to Earth. Please like and subscribe channel.